Hello, Gretov. Welcome back again to our sessions. This is our part 3 of trigonometry, and we're gonna be focusing on double angle identities. Okay, let's again look at the content outline. As you can see, in unit 1, we focus on grade 11 trigonometry, and we did some quick revision on some key basics on grade 10, and that was part of our part 1, right? It was our part 1. If you missed it, I'll just drop the link on the description, then you can go and watch it. And we did our part 2 on compound angle identities, right? We did our part 2 on compound angle identities, and today I want us to focus on double angle identities as our part 3 of our session. So this was taken from Platinum Mathematics Learner's book and also Mind Action Series Mathematics textbook and workbook. Okay, like I said, we're gonna focus on double angle identities, and here are the double angle identities. So if the expression sine 2a is expanded using compound angle identity, remember in session 2, that was our part 2, we focus on compound angle identities, right? So then the new identity will be like sine 2a is equal to sine a plus a, if you are writing it as like in a compound angle formula way, right? We'll say what? We'll say sine a plus a, because 2a is a plus a. So you know that from our part 2, we know that we can expand this sine a plus a. This is compound angle identity, right? It can be the same as what? As sine a, cos a, sine a. Remember, for sine, we keep the sign, so that positive will remain positive also there, right? So, but there's an interchange there between sine and cos, because you say sine cos, cos sine, with compound angle of sine, right? So now look, you have sine a, cos a, but these are like terms. Can you see sine a, cos a, and also this one cos a, sine a? We can say it's also sine a, cos a, in other words, right? So those are like terms. You're gonna add them together, you get what? 2 sine a, cos a. Can you see? So basically this is what we call double angle identities, to say, okay, actually if I have sine 2a, I can actually change it to be 2 sine a, cos a. So that's the first double angle identity, and we call that is a double angle for sine. For example, also someone can say, if I have sine 2x, right, we can now change it to be 2 sine x cos x. So I want you to understand what happens then when we go this side, right? So what actually happens is that if you have a double angle of sine, you multiply with 2. I want you to know this, right? You multiply with 2 and you're gonna divide the angle by 2, then you say sine x cos x. Okay, maybe you missed that. Okay, let me just repeat. Let me repeat it like this. If I have sine 2x, right, sine 2x, what do? I multiply with 2, then I write sine, then I write cos. Now to get the angles, you come to the original angle here, which is 2x, right? And you're gonna divide by what? By 2. So you multiply with 2, then you divide the angle by 2 when you want to expand the double angle of sine. So 2 and 2 cancel out each other, they will be left with x, so the angle will be x, right? So this will help you. For example, if they give you sine 4x, can you see sine 4x, right? So we know sine 4x can be written as a double angle identity of sine, to say it's the same as sine 2 into 2x. Can you see? So now we can see the double angle of sine. They are doubling the angle. So what do? We multiply with 2, then we write sine, we write cos, and then to get the angle, we're gonna divide the original angle by 2. So it will be 4x divided by 2 to give you what? It will give you 2x. Then we're gonna write 2x. So it's the same as sine 4x will be the same as 2 sine 2x cos 2x. But we'll just look at that as we proceed with this lesson, and as I give you much more examples like that. Okay. Okay, let's go to the one for cos, right? It's different. So we are talking about double angle identities, and now we want to focus on cos. I want to show you how they got the one for cos, right? So it's the same as for sine a bit. I mean, by expanding to say if I have double angle of cos and I have cos 2a, they're doubling angle, right? They're doubling a, so 2a. So it can be expanded using the compound angle identity that we focus on in our part 2. Then the new identity will be, if I have cos 2a, I can write it as cos a plus a, because I know a plus a is the same as what? As 2a. Remember, this is compound angle of cos, right? So I can expand it to be like, we know that for cos, it will be cos cos sine sine, right? Okay, so this is going to be cos a minus sine a, right? Can you see? Then if we try to simplify it, cos a times cos a, cos squared a. Sine a times sine a, sine squared a. So now we know that the compound, the double angle of cos can be cos 2a is equals to what? Cos squared a minus sine squared a. That's it, right? So you can see that the similarity that is between this double angle of cos and also the double angle of sine is that there are angles there. When you expand, they are all divided by 2. Can you see? It was 2a, but now the angles are now showing as being a, to show they have been divided by 2. Same as the double angle of sine, their angles there is showing like they've been divided by what? By 2. Okay, sorry about this. So then if for example I have cos 4a, right? So now I know this can be written as the double angle of cos to say to be the same as cos 2 into 2a. Can you see? So to just show you that really it was the double angle of cos, then I can expand it to say the rule says for double angle of cos it will be cos squared a minus sine squared a, but the angle are just divided by 2 there from the original angle. So this will be the same as cos squared. We divide the angle by 2, right? Because we have 4a, we divide by 2, it will be 2a, right? So it will be cos squared 2a minus sine squared 2a. Can you see? So that will be the double angle of cos. Can you see? So that's it. So, but let me just show you, because for cos, it can also be changed into two other, we can also get two other formulas for double angle of cos, right? So let me just quickly show you how we can do this. Okay, let me just quickly show you this. So we know that from the identity, I think this was done in the revision session. It was our part 1. You know that, and this is also just a revision from grade 11 and 10, I think. To say if we have cos squared a plus sine squared a, we know that that identity is equal to what? Is equal to 1, right? So we know that if we have cos squared a plus sine squared a is equals to 1, right? So from that identity, we can also deduce that cos squared a is equals to what? Is equals to 1 minus sine squared a. If we take this sine squared to the other side, so it will be minus sine squared a. So similarly, if I want to solve for sine squared a, I'll take my cos, let me show you, my cos squared a to the other side too. So we know that sine squared a is the same as what? As 1 minus cos squared a, right? So it means that, remember the formula for the double angle of cos, to say if I have cos 2a, it will be the same as cos squared a minus sine squared a. It means that I can also produce another formula, and we can also produce this formula to say we can come and replace our cos squared a by 1 minus sine squared a. Can you see? Because cos squared a is the same as 1 minus sine squared a. So where there is cos squared a, just gonna substitute 1 minus sine squared a, then minus, there is minus sine squared a this side. So these are like terms. So if we can conclude to say cos squared a can also be equals to 1 minus 2 sine squared a, when we add those like terms, to say minus sine squared a minus sine squared a. then it will be minus 2 sine squared a. So you can see the other formula now for double angle. Of course, although this is the standard one, you need to know this first, right? Then you can know these other two that can be produced, because if you know the first one, then it should be easier for you to know this. Okay, so the other formula now that can be deduced is to say cos 2a can also be written as 1 minus 2 sine squared a, and you need to know this formula, although they will give you in the formula sheet, but I do encourage you that go and practice a lot of questions. You'll see that in most questions you'll not really need to first change it into cos squared a minus sine squared a, but you just definitely need to go and change it to be 1 minus 2 sine squared a, and it's just how it was derived, by changing cos squared a into 1 minus sine squared a. Similarly, we can also do it this side to say I can actually change my sine squared a into what? Into 1 minus cos squared a, right? So when you change it, then you're going to remove by negative it to be minus 1 plus cos squared a. Then cos squared a, it will add up with cos squared a to give you what? 2 cos squared a minus 1. So you can see you can change the double angle for cos into what? Into 2 cos squared a minus 1. And in some question you'll need to just change it into this, because you'll find that you need to express them in terms of cos, so that you may cancel out some of the things, so that you can simplify like that. So here's the summary and sort of like the conclusion, the final thing that we can conclude to say, summary of double angle formula is to say sine 2a we know is the same as, so as what? It will be the same as 2 sine a cos a. Don't forget, right? So with the one for cos 2a, it can produce 3 formulas to say, and this is the standard one to say, it will be cos squared a minus sine squared a, right? It can also be written as what? As 2 cos squared a minus 1, or it can also be what? As 1 minus 2 sine squared a. And those are the formulas, double angle formulas that you need to know. Okay, let's go and look at an example now. Okay, let's look at example number 1 now. Okay, they're saying using the double angle formula of sine to expand, use the double angle formula for sine to expand the following. So A1, you're given sine 4a, right? We know that sine 4a can also be written as what? As sine 2 into 2a, right? So that I can just show you that this is a double angle formula. So then we can change it to say, for sine, it will be, we multiply with 2, then we write sine cos, and we divide the angle with 2, then we'll be left with 2a and 2a here. Can you see? Then we've expanded it using the double angle for formula for sine. Let's go to number 2. As for number 2, you're given sine 50 degrees. Very interesting. Sine 50 degrees. So this can be written, you must write it as double angle, like doubling the angle, and right, as you're multiplying the angle with 2. And we know that to do this, we can write it as what? As sine 2 into 25 degrees. We know that 25 degrees times 2 is 50. Then we can express it to be, we multiply with 2 sine, we divide the angle with 2. So 50 divided by 2, it will be 25. It will be 2 sine 25 degrees multiplied by cos what? Cos 25 degrees when we use double angle formula. Number 3, we have sine A. Very, very interesting one. Quite challenging, but interesting. Sine A. So you must write it as double angle formula, right? So how can you do this? We can say it's sine 2 into a over 2. Can you see? Because you know that it's still sine A, because 2 times 2 will cancel out each other, and it will still remain sine A. Can you see? So it's quite interesting like that, because you know 2 times 2 can, 2 times a over 2, 2 and 2 will cancel, and it still be sine A. So if we express it using double angle formula, we multiply with 2, then we say sine, we divide the angle with 2, so it will be a over 2. A over 2 multiplied by cos A over 2. Can you see? Then you have expressed it using double angle formulae. Okay, let's go to B. Okay, with B, number 1, we are given cos 6A, right? Cos 6A. We can write it as double angle of cos to say to be the same as cos 2 into what? Into 3A, right? Because 2 times 3 is 6. So I'm just writing as double angle for cos in that way. So we know this can be changed into what? Remember, for cos, if we have cos 2x is the same as what? Cos squared x minus sine squared x, right? So even this one, it will be the same as what? As cos squared, we divide the angle by 2, so it will be 3a minus sine squared 3a, right? Or someone can choose to write it to be like 2 cos squared 3a minus 1, or someone can say it's the same as 1 minus 2 sine squared 3a. I mean, using those other two formulas that we just showed you in the previous slide. Okay, so but let's just end it there, but you can also change it to be that other way, right? Okay, so let's go to 2. As for 2, we are given cos 80, right? Cos 80 degrees. So as a double angle of cos, we can write it as cos 2 into what? Into 40 degrees. Remember, for cos, it changes to be cos squared angle minus sine squared angle. So this can be written as what? As cos squared 40 degrees minus what? Sine squared 40 degrees, in that way. Okay, let's go to 3. Interesting one. You have cos A. Can you see? Cos A. And this is where most learners don't actually believe that this can be written as double angle of cos, because you have to be manipulative to manipulate this expression so that it can really show that it can be written as double angle of cos. So that's where it gets a bit challenging. But you can see this can be written as cos 2 into A over 2, right? I've just written it as double angle of cos because I know 2 times A over 2, it will still remain cos A, because 2 and 2 cancel out each other. So because this one is for cos, it will say cos squared angle divided by 2, so it will be A over 2 minus sine squared angle divided by 2 to be A over 2. Okay, so that's it. Okay, let's now look at example 2. Now from example 1, you know how to move from double angle identities into their expansion, right? So you also need to know, and this is very, very important, because many learners just know how to move from double angle into their expansion to say, if I have sine 2x, it will be 2 sine x cos x. If I have cos 2x, it will be cos squared x minus sine squared x. But you don't need to only know that. You also, very, very important, I've seen it while solving trigonometric expression, they also need you to know how you can move from those expansion back to the double angles, right? So you need to know how, if you are given an expanded expression, right, you also need to know how you can move back, right, back to the double angle. So this that's why I just put this example too, so that you can get this idea. And this obviously was taken from Mind Action Series textbook. Okay, so thanks to them who created this content. Okay, let's look at this. It says right as the sine of single angle. So they just also want you to know how you can move from the expansion back to the double angles. So 1, you are given 2 sine 3 theta multiplied by cos 3 theta. Okay, now I need you to know this. If I was given sine 2x, to go in front, to expand it, I'm going to say we multiply by 2, we say sine, we say cos, we divide the angle by 2, then it will be xx, right? So you also need to know how to reverse. Very, very important. When you reverse, what do? You divide the whole expression by 2, 2 and 2 cancel out each other. Then on sine, you multiply the angle by 2. Then you'll get sine 2x. So this is a way that you can actually internalize or conceptualize this to sort of like get an understanding, or sort of like a memorizing way to return back, right? That's the strategy. So to go in front, you multiply by 2, then you divide the angles by 2. But to reverse, you divide the whole expression by 2, 2 and 2. Then on sine, you're going to multiply the angle by 2. Then it will give you sine 2x like that, right? Same as if I had, okay, let's just look at an example and I'll show you this. Now I'm given this expression here. I need to return back, right? What will I do? You do it separately, don't do it here, right? So I'm just going to do it separately. 2 sine 3 theta cos 3 theta. I can see because it's sine and cos, is double angle for sine. So divide the whole expression by 2. 2 and 2 cancel out each other. Then you're going to multiply when there is sine the angle by 2. Then it will give us what? Sine 2 into 3 theta, which is going to be sine 6 theta. And that will be the answer for that one. So you need to know how to reverse, right? Let's just look at number 2 now. Again, you are given 2 sine a over 2 cos a over 2. We can clearly see this is double angle for sine because we have sine, cos, and they're multiplying by 2. So what do? We divide the whole expression by 2. Let me just show you here separately. We divide the whole expression by 2. 2 and 2 cancel out each other. Then for when there is sine, we multiply the angle by 2. So it will be sine 2 into a over 2. Then 2 and 2 will cancel out each other. You'll be left with sine what? Sine a. Very, very important there. Okay, let me just show you the last example, which is number 3. Very interesting one. You are given 4 sine x cos x. How do you return back? Let me just write it here. 4 sine x cos x. How do you return back? You divide the whole expression by 2. 4 divided by 2. They won't cancel out each other as in like these two expressions. 4 divided by 2 to give you 2, right? You divide by 2, then you double the angle for sine there. You multiply the angle by 2. So it will be 2 into sine 2 into x. So that one will be 2 sine 2 into x, because we also multiply the angle by 2 there. So this one will be 2 sine 2x. Then that's it. Can you see? Okay, let's go and work out the one for cos now. B. Okay, the one for cos, example 2, B. 1, you are given cos squared 2 theta minus sine squared 2 theta, right? So we can see this is double angle for cos because we have cos squared minus sine squared. So if you know the standard formula to say cos 2x is the same as cos squared x minus sine squared x, you really know for sure if you have this, it's double angle for cos, right? So also you need to know what they do. This is quite different from what they do in sine. Here for cos, they just double the angle, right? So if I have cos squared x minus sine squared x, I know it's double angle for cos, so I'll write cos, then this angle here, we double it, we multiply it by 2, then it will be cos 2x. So that's the difference with the one for cos. So if I have something like this, then we know for sure we just double the angle, so it will be cos 2 into 2 theta, then it will be what? Cos 4 theta. So it's simple like that, the one for cos. Okay, let's also look at number 2. You have 1 minus 2 sine squared theta, right? 1 minus 2 sine squared theta. We can see that this is the other part in which our cos can be changed. Remember for cos, let me delete this. For cos, if I have cos 2x can be changed into cos squared x minus sine squared x. Can also be changed as 1 minus 2 sine squared x can also be changed as 2 cos squared x minus 1. You must know all these three formulas in which your double angle for cos can be changed into. So you can see this is the other part of it, same as that one. So we know it's double angle for cos. It can be cos. We just double the angle there to be 2 times theta, which is cos 2 theta. Can you see? That's it. Let's go to number 3, the last one. You're given sine squared theta minus cos squared theta. Can you see? They're just interchanging something there. We know that for cos, it must be cos squared theta minus sine squared theta. But in this one, they are starting with sine squared theta minus cos squared theta. And this is a trick that they mostly like to use, because they just know students will just say, okay, because this one is sine squared theta, cos squared theta, you just change the answer to be, oh, then it's cos 2 theta, and it's wrong, right? So you must know the rules for double angle for cos. It starts with cos squared x minus sine squared x. So if I needed to start with cos, you'll see it's going to be minus cos squared theta plus sine squared theta. Can you see? If I just arrange those things properly. So if I take the common factor of -1, I'll be left with what? Cos squared theta minus sine squared theta. Now it's in a proper way. Can you see? It's in a proper way. Now I can say minus, because I know cos squared angle minus sine squared angle is double angle for cos. I can change it to say cos, and I double the angle. So it will be theta times 2. Then this will be minus cos 2 theta. Can you see? So it's negative. It's not positive, because they started with sine, and we know from the thing it must start with cos. So most of the time, the more you practice, you just see, oh, if it's like this, they just interchange. Then it will be negative cos 2 theta like that. You just go straight without showing the workings like that. The more you practice, right? Okay, example 3. And I'm just putting these different examples so that you can get an idea of how they can ask you to use these double angle formulas, right? To how you can use them and all that. So the question goes like, calculate the following without the use of a calculator. I told you in trigonometry, this question will always be there, right? You'll always see a question that says calculate without using a calculator. In other words, in trigonometry, they are saying you must also be thinking and using your knowledge about special angles. That's it. Special angles. So there are questions you know for sure what they require. So they want you to also relate with your knowledge of special angles. That's why they know without using a calculator, special angles. If you know the triangle, you can be able to get the answers, right? Let's go quickly and start with A. You are given 2 sine 15 degrees multiplied by cos 15 degrees. Okay, sorry about the background noise. 2 sine 15 degrees times cos 15 degrees. We can see this is 2 sine and cos, and is a double angle for what? For sine, right? So we can change it to be, we say for sine, if we want to return back, we divide the whole thing by 2. This will cancel this, and we multiply when there is sine the angle by 2. So it will be changed into sine 2 into what? Into 15 degrees, and this will give you sine 30 degrees. Can you see? And now let me just delete this. I was just showing how you can do it. So, and now you have sine 30 degrees. 30 degrees is a special angle, and you know from the triangle to be equals to what? 1 over 2. 1 over 2. Let's go to B now. B, you are given 1 minus 2 cos squared 22.5 degrees. Okay, so look at this now. You have 1 minus 2 cos squared 22.5 degrees. Now, if you interchange it, if you see this one is for cos, right? Double angle for cos. Remember, we can change cos 2x into 1 minus, it can be changed into 2 cos squared x minus 1. But now they interchange. They are starting with 1. Can you see? They are trying to trick you, because for cos, we know it can be changed into this. The only one that starts with 1 is for sine. I mean, for cos, but when we are changing it using sine, to say 1 minus 2 sine squared x is the only one that we can start with 1 here, and that one. But with cos here, they're just tricking you. So the first duty you can do is to take one negative as a common factor, right? Minus as a common factor. Then I'll be left with what? With minus 1 plus 2 cos squared 22.5 degrees, right? So if I write that properly, we have minus there, and I can start with 2 now to say 2 cos squared 22.5 degrees minus 1. Can you see? Now I've rewritten it in a way that it aligns with the double angle for cos. Then we're gonna change it now. We know that this can be changed back into this, so it's the same as what? As cos. Then we double the angle, so it will be 2 into 22.5 degrees, right? So you must know the rules really to be able to do this. So it's minus into cos what? Cos 45 degrees. And we know that cos 45 is what? Is a special angle. 45 is a special angle. It should be changed to 1 over root 2. So using your calculator, mostly I think they'll just say root 2 over 2. So because there's negative, we just put negative. So it's the same as that one. So that's the answer for that one. Okay, let's go to C. Okay, C is quite interesting. You're given cos 15 degrees plus sine 15 degrees all squared, right? So we know this can be rewritten as what? As cos 15 degrees plus sine 15 degrees multiplied by cos 15 degrees plus sine 15 degrees. When we expand, right, we can now expand to see this one will multiply with this one to give us what? Cos squared 15 degrees. This again multiplying with the second one there, it will be what? Cos 15 degrees multiplied by what? By sine 15 degrees. Then we come to this one now, right? So this one is gonna multiply with what? With this one, the first one here, and it will be what? To be sine 15 degrees multiplied by what? By cos 15 degrees. Then again, this one is going to multiply with the last one there. When we expand, then it will be sine squared 15 degrees, because it's sine 15 times sine 15, right? Okay, let's see. So we now have cos squared 15 degrees. Can you see that these two are like terms? It's cos, let me highlight it maybe using a green color. Can you see they are like terms? It's cos 15 sine 15 plus sine 15 cos 15. They are like terms, right? So they can be changed into what? Into 2 sine squared 15 degrees cos squared. It's not squared, man, sorry. They can be changed into 2 sine 15 degrees times cos 15 degrees, and we have plus sine squared 15 degrees. Can you see? Sorry about that. Then look at this now. We have a rule. Can you see? We have a rule. We have cos squared 15 plus sine squared 15. And we know the answer for that, right? Cos squared 15 plus sine squared 15 is what? Is 1. Remember from the revision in our part 1, we covered this identity to say if you have cos squared x plus sine squared x is equals to 1. Whether you started with this one, with addition, it does not matter. So it will be 1, right? So that identity was taught in grade 11, and also we covered it in the revision. Okay, so it's 1 plus, look at this, we have 2 sine 15 degrees times cos 15 degrees. Can you see? This is double angle for sine. Can you see? It's double angle for sine because it's 2 sine 15. And how do we go? We have 2 sine 15 degrees cos 15 degrees. So if we want to return back, we say we divide by 2. This one will cancel this. Then we double the angle. We'll multiply the angle by 2. Then it will be sine 2 times 15 degrees. Why I don't focus on the one for cos? Because this one is double angle for sine, right? We know it's double angle for sine. If you know the rest, we know it's double angle for sine. So you must double the angle for sine there. So that's why we don't focus the one for cos. So it will be what? To be sine 30 degrees. Can you see? To be the same as sine 30 degrees when we return it back there. Okay, and just clear this and put it there. Then we know this one for sure. When we divide by 2 and double the angle for sine, it will be what? Sine 30 degrees, right? Because it's sine 2 into 15, which is sine 30 degrees. So this will be 1 plus 30 degrees is a special angle, which is the same as what? As 1 over 2. I'm looking for my calculator. 1 over 2. is the same as 1 over 2. Where is my calculator? Okay, I think when it's simplified, it's going to be 3 over 2, right? It's going to be 3 over 2 because 2 is lowest than 2 plus 1, 3 over 2. Then that's the final answer for that. Okay. Okay, let's now look at example number 4, and this is one of the most important example because it relates what we have been doing in this session, which is double angle identities, with also what we covered in the revision in part 1 when we were revising grade 11 and 10 trigonometry, where we also learn about reduction formulas, how you can reduce trigonometric ratio into simpler trigonometric ratio. So you have to combine that knowledge in order to solve these trig expressions. Okay, number 1, you are given sine 35 degrees times cos 35 degrees divided by tan 225 degrees multiplied by cos 200, right? And they're saying evaluate. In other words, they want you to simplify this, right? So to get the final answer for this. Okay, so look at this. We have sine 35 times cos 35. What comes to your mind? It's double angle of sine, right? Because we know if I have sine 2x is the same as 2 sine x multiplied by what? By cos x. So if I have sine x times cos x, I must think of double angle of sine as in like what we have been doing in this session. So I have sine 35 times cos 35. So we can think of double angle of sine, right? So how do we go back? Remember, from this expression, we want to go back there. We said if you have something like this, sine cos, then to go back to that one, we divide the whole expression by 2, then we'll get 1 over 2, right? Because here there is 1, so it will be 1 over 2. Then on sine, because it's double angle for sine, we multiply the angle by 2, so it will be 2 sine 2 into 35 degrees, right? So we can just rewrite it that one like that. So it will be 1 over 2 sine 2 into 35 degrees. So that's how you can simplify that one. Okay, so let's go under there. We have on the denominator, we have tan 225 degrees. So look at the Cartesian plane here. So from your Cartesian plane, you can see that if I have tan 225, we have to use the reduction formula in order to reduce that trig ratio, right? So how do we do that? You check your angle 225 degrees is between what? It's between 180 and 270, and here we have tan, right? So it's between 180 and 270. So we can rewrite it, and it's defined as 180 plus theta. It means that tan 225 can also be written as tan 180 degrees plus an angle. So plus theta. So we said 225 minus 180 to give you 45. So they added 45 on 180 to get 225. Okay, so we can write it like that. Multiply by cos 200. Let's check 200. 200 is also between 180 and 270. Can you see? We have 200 between 180 and 270. Then we can rewrite 200 as, because there is defined as 180 plus theta. So it can be written as 180 plus certain angle. 200 minus 180 is 20. So it's 180 plus 20. It will give us 200. Can you see? Okay. Okay, now we can go and simplify now. We have 1 over 2. Sine 2 times 35 is going to give me what? 70, right? 70 degrees over tan 180 plus 45. Let me quickly draw a Cartesian plane here. Okay, from the Cartesian plane, when we say 180 plus angle, it's the third quadrant where there is tan, so tan will remain positive. Then when we reduce it, it will be tan what? Tan 45 degrees. Don't forget, according to the reduction formulas that we learned in the revision, right, in part 1. Multiply by cos 180 plus 20 degrees. So 180 plus theta is on the third quadrant, and we have tan. So cos will be negative, right? When we reduce it to be negative cos 20 degrees, right? So let's go. Also here we can reduce this one, right? Sine 70. So 70 degrees is between 0 and 90, and there we can define it as 180 minus theta. So we can rewrite sine 70 a sine 90 degrees minus a certain angle that when we subtract will be 70. So we say 90 minus 70 is 20. So if we subtract 20 degrees, it will give us 90 minus 20, it will give us 70 degrees, right? Okay, look at this. Tan 45 degrees under in the denominator. 45 degrees is a special angle. It's a special angle. So we know from special angle 45 is the same as 1 over 1, right? So it's 1 over 1, which is 1, multiplied by minus cos 20 degrees. Okay, let's go and simplify on the numerator. We have 1 over 2 sine 90 minus 20. So 90 is a co-function, co-ratios, all that. They can change. Sine has to change into what? Into cos. But look at 90 minus angle. It's where all of them are found. So hence our answer will remain positive cos. Then when we reduce it, it's going to be cos what? Cos 20 degrees. Divided by 1 over 1 times minus cos 20 to be minus cos 20 degrees. So cos 20 cancel with cos 20. 1 over 2 divided by minus 1. Then the final answer will be negative 1 over 2. Negative 1 over 2 when we evaluate this. So you can see that in this example 1, we use our knowledge. If you don't know how you can reverse those that expression back to double angle identity expression, you wouldn't be able to solve it and evaluate and get the answer, right? You wouldn't be able to do that. So it's very important that when solving trig identities, you must be thinking of all the knowledge that you have learned about reduction formulas, about co-ratios, also about compound angle identities. You also need to think also about double angle identities, because all that knowledge can just be combined in one question like this, and they can want you to simplify and all that. Okay, let me just enhance your knowledge by doing number 2 and also lastly B. Okay, number 2, you're given sine sorry about this. Okay, let's see. Sine 36 degrees over sine 12 degrees minus cos 36 degrees over cos 12 degrees. Okay, you have to evaluate this one. In other words, you have to simplify. I can start by taking my lowest common denominator to be sine 12 degrees. Just take all of them and what? And cos 12 degrees. Okay, so now it's gonna be, if you want to get the answer on top there, you're gonna take this one and you will multiply it with this whole expression to get the answer on top, right? So it will be sine 36 degrees over sine 12. You are multiplying with what? With sine 12 degrees times cos 12 degrees. So this cancel this. You'll be able to sine 36 to be sine 36 degrees multiplied by what? By cos 12. Okay, I see this question is going to be interesting. Minus this side, just also going to multiply with my lowest common denominator on this one to get the answer on top, right? So say cos 36 degrees over cos 12 degrees multiplied by sine 12 degrees multiplied by cos 12 degrees, right? Cos 12 and cos 12, they cancel out each other. You are left with cos 36 degrees multiplied by what? By sine 12 degrees. Okay, interesting question. Okay, look at this now. It's now relating to what we covered in part 1 and in this session, right? I mean in part 2, which was compound angle identities, and also in this session. So you should be thinking of that, and the more you practice, you'll be able to relate and connect this knowledge from all this session in one question. Okay, so you have sine, cos, sine. What is this? It's compound angle of sine. It's compound angle of sine. So you can rewrite it as sine 36 degrees minus what? Minus 12 degrees. My pen is acting up now. Okay, it's fine. So it's sine 36 degrees minus 12 degrees. Can you see? Because it's compound angle of cos, we can reduce it to be like that, because we learned in part 2 that with compound angle, I mean it's compound angle of sine, and we know it by the interchange of sine and cos. Sine, cos, cosine. So if it's like that, we know it's component angle sine. We can rewrite it as sine 36 degrees minus 12. And for sine, we keep the sign. Hence, I didn't change that negative to be positive. It remains negative because sine, we keep the sign, right? So let's go under here. We have sine 12, cos 12. Can you see? So now this relates to what? To double angle of sine, not compound angle, because this is double angle. Look at sine 12, cos 12. So remember sine 2x was the same as 2 sine x cos x. So that's why we're saying if you have sine 12 cos 12, it's what is double angle for sine. So you can change it. And how do you change it? You divide the expression by 2 and you multiply the angle on sine by 2. Okay, let me just show you here. We divide the whole expression by 2. We have 1 there, to be 1 over 2. Then we're gonna double the angle there by 2. We multiply by 2, so it will be 2 into 12 degrees, right? So it will be what? 1 over 2 sine 24 degrees. So we can replace that one by 1 over 2 sine 24 degrees. Can you see? Okay, let's go and simplify this. It's gonna be sine 36 minus 12. We can reduce it to be 36 minus 12. It's gonna be what? 24. Can you see? Sine 24 there. Let me just delete this. It's gonna be sine 24, then divided by 1 over 2. So this is 1 over 2 sine what? Sine 24 degrees, right? So sine 24 and sine 24 will cancel. We'll be left with 1 divided by what? Divided by 1 over 2. 1 divided by 1 over 2. And 1 divided by 1 over 2, you can just use your calculator. I think it will give you 2, right? Because it's 1 divided by 1 over 2. If I change it to be 1 times 2 over 1, then the answer will be what? Will be equals to 2. So you can just use your calculator from there. Then you will get an answer of 2. Also, you can prove this because these are just angle, right? And also with number 1, you can just prove this. You can punch this on your calculator. You get the answer. And you'll find that you'll still get the 1 over 2 that we gotten previously. I think it was minus 1 over 2 if I'm not mistaken. And this one we are getting what? Here we are getting the answer of 2. And you can punch your calculator to prove it, right? Okay, let's look at the last one, which is B. Okay, with B, they are saying express sine 3 alpha in terms of sine, right? In terms of sine, they mean it must be expressed in terms of sine only. So to do this, we can rewrite 3 alpha as what? As 2 alpha plus alpha, because we know we learned about compound angle identities. So 3 alpha, we can't write it as double angle to be sort of like complicated and all that. So we can just rewrite it as in like in compound angle like that. We expand the angle, we break the angle to be 2 alpha plus alpha. So for sine, we know it will be what? It will be sine 2 alpha, then cos what? Cos alpha. For sine, we keep the sign, it remains positive. Then we say cos 2 alpha, then multiply with what? With sine alpha. Can you see? Look at this. We have to express this in terms of sine only. So we can change this using the rule. We can see the rule, right? Sine 2 alpha is the same as 2. We multiply by 2. Then we divide the angles by what? By 2. Then it will be sine 2 sine alpha cos alpha. Multiply by what? There is multiply by cos alpha there. Plus cos 2 alpha. Remember, we have to change this in terms of sine, right? So I can't change cos 2 alpha into cos squared alpha minus sine squared alpha. I have to change it into what it is in terms of sine, right? So, and that one we know is the same as 1 minus what? 2 sine squared. We divide the angle by 2, we'll be left with alpha multiplied by sine alpha there. Can you see? So it's the same as 1 minus 2 sine squared alpha multiplied by sine alpha there. Okay, let's simplify. Cos alpha times cos alpha, it will give us cos squared alpha, right? So we have 2 sine alpha multiplied by cos squared alpha, plus if I remove by sine alpha here, sine alpha will multiply with 1, it will still be sine alpha. Sine alpha multiply with this one, it will be minus 2 Sine squared alpha times sine alpha, it will be minus 2 sine exponent 3 alpha. Can you see? Then let us go to sine alpha. We are just only left to change this so that all these things can be expressed in terms of sine alpha, right? So we need to change this one. We know the rule cos squared alpha is the same as 1 minus what? Sine squared alpha, right? We have plus sine alpha minus 2 sine exponent 3 alpha. Okay, so let's remove by 2 sine alpha here to multiply with 1. It will be 2 sine alpha. Then this one will multiply with this one. It will be minus 2 sine exponent 3 alpha plus what? Plus sine alpha minus 2 sine exponent 3 alpha. Then we can add the like terms, right? Let me just put my final answer here. So when we add the like terms, we have minus 2 sine exponent 3 alpha minus 2 sine exponent 3 alpha. It will give us what? Minus 4 sine exponent 3 alpha, right? Then 2, or maybe I can use a different color to show 2 sine alpha plus sine alpha. It will give us what? 3 sine alpha. So it will be plus 3 sine alpha. Can you see now? We have expressed this expression into sine alpha only because now we have sine alphas there. So that's it. We have expressed it. And you notice that while expressing, we were using the rules. We use compound angle identities. All those compound angle identities for sine, you had to know compound angle identities. You had to know also double angle identities. We had to change these double angles here, right? With for cos, because we had to change into for sine, we had to change it into that one that it changes to sine, like that. So you can see that this knowledge can be integrated, all integrated in one question. So you need really to know these rules and how to change, how to reverse back, and how to go in front. Okay, great stuff. I think this marks the end of our session. This was our part 3, where we were focusing on double angle identities, although our last part of this session also integrated the other 2 sessions that we have been covering, because really trigonometry cannot, I can say it does not work alone. It needs those key basics. Hence, we had to relate knowledge in part 1. I will also attach the link for part 1, and also we had to relate knowledge of part 2 of compound angle identities in order to solve also problems related to double angle identities. Otherwise, that's all for me. Watch out for session 4. That is our part 4, where we're going to be focusing on proving identities, also using double angle, compound angle, and also part 1 of the revision. Okay, otherwise, that's all for me, and enjoy the rest of the day. Thank you for watching, and goodbye.